Welcome to our design series. We are currently treating our module 6 in the structural design of two-story building using two powerful Autodesk software, that is the Revit Structure and Robot Structural Analysis Professional. So in our previous lesson, we have run the analysis of this structure, and in this model we want to perform the design of the reinforced concrete members. So let's just proceed and do the design straight away. Okay, so I'll close this. Then I will come to this section shape, click on the section shape. So I will come to design. So when you want to perform design for your structural members, after you might have finished performing the analysis, so the next thing is to run the design. You click on design, then you click on require reinforcement of RC beam and column. So we want to consider the design of RC beams and column. So you click on that. Okay, so this is our model and we want to perform the design. So before we perform the actual design, there are some settings that we need to do. So the first setting is for us to define our RC members. We define the RC members. So let's look at our checklist. So you design of RC members. So you select design, you select RC member require reinforcement. Then you click on RC member type. So we want to carry out the setting right now. So you click on new, definition of a new type of concrete member. So you click on that. So when you click on that, under column, you don't check anything. We allow everything to remain in default. So there is nothing that there is no change that we are going to effect under the column bed. Under the beam, we are going to do some setting for the beam. So under here we can just edit this, and we can just type a new name. We call it standard. Let's use the word standard beam. So when you click on that, when you change the name, so you come here under span length, you select in axis. Then here support width. So we allow this. Then we check this according to structural geometry. So the design must be done according to the structural geometry. Then after you have selected this, then you come to admissible deflection. So under admissible deflection, we allow 25 mm to be our admissible deflection. Okay, so once we have done that, we don't have any other thing to do. So everything will remain at default. So you can now save this. You can save this as your standard beam. So we can click and then we close. So we are done with that. So the next setting we will do will be the RC member calculation parameter. So you click on RC calculation parameters. Though we have done some setting, but I still want you to see how this setting is being done. So you click on new. So when you click on new, you check this as in structural model, So meaning that the material, the name, the characteristic strengths, the unit weights, once you check this, it will just bring it as it is in the structural model. So look at what is going to happen. So once I click that, you will see that the material name is the Euro code. The name of the material is grade. This is grade 2025. Then the characteristic strength is now 20 megapascal. Then we have the unit weight, then the creep coefficient, and then here you come to where we have the exposure condition. The exposure condition is XC1. Now this exposure condition has to do with our cover. It has to do with our cover. So let me quickly show us in our calculation sheet. So here we have now for this structure, the structure falls under this category and 50 years intended lifespan, building and other common structures. So here you have the exposure class, and since our service time years falls on this category 4, so our exposure class will be X. You can choose exposure class either XC1, XC2, or XC3. We are using XC1 because our concrete cover exposure condition is under XC1. So we look at the exposure condition here, XC1, dry or permanently wet. So under this concrete strength, which is 2025, so we have the exposure condition to be XC1. So that is why we select XC1. So we come here, we select XC1. Okay, then structure class is S4. Structure class is X4. As you can also see here, that our structural class is S4, which falls under these categories. Okay, so we are done with all those settings. So we can now change this to standard. Can change this to standard. So under the calculation parameter definition, so we can save. So we have this already. So we can just, maybe we can add one to it. Let's just add one to it. Can add one to it and save. So we have saved that. Okay, so we can close. So now that we have done that, so the next thing we will do now is for us to select the structural member that we want to design. So we will start with beam. We're going to start with beam. So let's start with beam. So when you look at this, is this place indicate under members you have all, but I want to design this member one after in their respective group. So I will design all the beams, then after I will design all the column. So let's click to select the group. You click here. So when you click here, you come to group. So when you come to group, we want to design our beam our roof, our first and second floor beam, then we will also design our roof beam. So when you click on that, you click on this. When you click on that, you click on this. So the to bring all the members to this group. So you close. So when you close, you come to list of cases. So we are going to look at ultimate limit state. So you click on ultimate limit state. When you click on ultimate limit state, you come to combination. You click on ultimate limit state. You add. You close. Then you come to serviceability. You click that. Then you click combination. You click this. Then you close. So we are done with that. Okay. So we come to this dialog box where we are going to effect our changes. So here I will click on this. So when I click on this, I right click, then go to field special. Field special. So under field special, I can now select on standard one because we have already selected, we have already edited that. So I will just put standard one. Say the operation will cause the changes in the database. Yes. So I say okay, yes. So standard one has been affected. Okay. So here under material, I want to change my material. So I will click on it, then right click, then go to field special. Go to field special, then I'll come here, select my concrete class or concrete, yes, concrete class. So this will give me, let me look for 2025. Yes, so this is 2025. So I'll click on it. So it has changed this to 2025. Okay, so here under type we have the reinforced concrete beam. So we are going to change this. We are going to change this to what we have saved already. So we're going to change this to standard. So we look for standard. So we are going to change this. This will be changed to standard. This will be changed to standard. Change this to okay. So we have changed that beam name from standard to beam one. As you can see, when you look at here, beam one, all the settings for the standard still remain the same. So we are now using beam one here. So we have to select everything that has to do with beam one. So you have to do it gradually. So we have to select this. So what I will do, I will just pause the video and just finish the setting so that this will not really take much of our time. So let me just do a very few one just for you to see how I'm selecting it. So we select this. Now while you are selecting your beam one, you have to also take note of where the beam stops. So as you are doing it, you have to observe this section. Have to observe this section. So this is where the beam stops. So from here we have our column. So we are not going to. So we have finished all the selecting. So we have finished all the selecting now. So we can now run our design. So we can run our design now. So to run the design, you simply click on. Now, when you look at this, when you look at this beam and this beam, you will not see anything. You look at this column, you won't see anything. But the moment we are done with the design, you will see that the output will come out here. So we are done with that. So we can now click on calculate. So it's saying that structural calculation result of the are not out of date. Okay, so we click on structure calculation. Okay, so the design is complete. So you can close. The design is complete now. So you can see here that all the beams have been designed. All the beams have been designed. All the beams have been designed. All these beams. So for us to know, let's click on this beam. So when you click on here, you will see the reinforcement. So for this particular beam, this is the reinforcement. Now, top required. Under top, this is the the area of reinforcement. So here for the top reinforcement, we have 3H16, 3H16. For the bottom, we have 2. For the bottom, we have 2. So when you click on each of these, you will see their respective reinforcement. So once you click like this one now, when I click on it, I will have, this is the area of top reinforcement, and which is the provision is 2H16. Then for the bottom, we have 2H16 also. So you can check this out. Now the beautiful thing about this software is that once we are done with this, we can go to Revit and update this design. Now what we mean by updating this design from Revit is that all the reinforcement that has been provided or has been designed for. But once we go to Revit, we can update it. Then we can use the Revit environment to now carry out the detailing of each of the structural member. Okay, so we are done with beam. So let's go straight to the column. So let's design the column. So to design the column, we also do the same approach, but we are not going to do any further setting again. We're not going to do any further setting again. So what we do here, we simply come to this, then we come to group, then we click on CT1, then we close, then we also do the same setting for the combination, then for the serviceability limit state. So we also do the same thing and we close. So when we finish that, we just calculate. Okay, so all the column has been designed. So we have successfully designed our beams and our column. So by the time you click on column, you will see the reinforcement for each of these column. So you can now see the reinforcement for each of the column. So you can see for this one now. So this column has 4Y16. So we have 2 here, we have 2 here. So you can see their respective reinforcement. Okay. So as you click each of these, you will see those reinforcement where this is the reinforcement for it. When you click the next one, you will see, if you click on this one, you will see the reinforcement. If you click on this, you will also see the reinforcement. Okay, so that is how you carry out the design of the structural members using the the require RC reinforcement. Okay, so close. Let's quickly close. Okay, so now the next thing we want to do, if time will permit us, is just for us to design the footing. So we want to design the footings now. We want to design the footing now. So to design the footing, we are going to use the provided uh, this thing. So to do that, what I will do, because I want to design the footings, all the footing at once. So what I'm going to do right now is, let me click on the base. I'll click on the base, then come to plan. I'll come to plan. I'll come to plan. Come to plan. Then I will highlight everything here. So when I highlight everything, I will come to, I will either go to design from here, start from here, or I will quickly come to this. I will quickly come here. So let me highlight it again. Then come here, provided reinforcement of RC member. So I'll click on this. So this dialog box will pop up. So when this dialog box pop up, you click on manual combination. So you click on OK. You click on OK. Now, when you click on OK, it's telling you no selection. There is no problem about that. So what you do is you come to this. So when you come to this, you double click on this. So when you double click, the footings will come out. So the footing will come out. So when the footing come out, you can start from general. So I want to, it's a 2 floor. So let me assume 1.5 first. Let me assume 1.5 first. So 1.5 by 1.5, which is a square column. Then for my footings, for my footing thickness, I will assume 0.45. Then for the height, from base, from the top of the base up, I will use 75 750 mm. Then for the blinding, I will use 75. Then I will come to piers. No, then here I will maintain 225. That is a column size. Then for this, we also have 225 and 225. Then under optimization, you click on optimization step, then change it to 0.1. Then you can click apply. Okay, so we click apply. Then let's do our setting. So we start with the story parameter. So here we are using a exposure environmental class of XC1. Then our structure class is ACE4. So we can save this. Let's save this as, let me use it, save this as 16. I'm saving it as 16. Okay, I'll click on OK. So I will come to, I've done this, I will come to calculation option. Click on calculation option. Then under general, under general, the column cover is 40. Taking 40 as my cover to column 40. Then under deviation, I have 10 mm standard deviation, so which is okay. Then under concrete, I will come here, select my concrete, which is 2025. So 2025. Then under longitudinal reinforcement, I will select this, which will now give me the 410 megapascal. Then ductility class is class C. Ductility class is class C. Let me see if I will be able to quickly show you where that class C. So you see here that these are the different classes of ductility. So we have the class A, low ductility steel made from cold drawn wire. We have the class B, medium ductility steel, a specific grade for reinforcement made. Then we have the high ductility steel, a specific grade for rebar used for cement steel. So this is the class that our own steel belongs to. So we class C. Okay, so we have selected that. Then we come here. Our longitudinal bar is going to be H16. It's going to be H16. Then we go to the traverse. We go to the traverse. Then we select the steel grade. The same thing. Then we come here. We select. We can select 12 here. And select 12. Then we come to the additional. So we also select the steel grade. So we can use H16. So we are done with that. So we can also save this as 16. We save that as 16. Then we okay it. Okay, so we move to reinforcement pattern. We move to reinforcement pattern. So we are not going to use piers here. So under footings, we have this. Under footing, we have this. Then we have H16 as our footings. Then we go to advanced. Now we go to advanced. So we are not going to have first and second layer. So we click on this one because it's not a combined footing. So we click on this. Then you click on OK. Then you go to dowel bar. Dowel bar here is just the starter bar. So we have already designed our column reinforcement. So let's just allow this 4 to remain. Just allow the 4 to remain. Then this diameter H16. Then what again? Shape. Under shape. So here we will have hook. That hook will be 90 degree. Then we have this one also 90 degree. So I think we have done all the setting now. So we can save this also as 16. So we click on OK. Then the next thing is for us to OK. Click on OK. Then move to load definition. Now because we have actually run the analysis, so our load case is already inbuilt. So you come here, click on design. So when you click on design, the load that you are going to use for this footing design will come up automatically. So when you click here, you will see that this is under serviceability. So we have this load under serviceability, and we have this one under ultimate limit state. So you can close. Then under this one, soil definition, since we don't have a soil report, so what I normally do is just to make a little assumption here. So what I will do here is that I will just put 1 meter here, then come to this one, select my soil tab. Then I will say let it be clay, gravel. No. Um, let me click on this. Let's click on that. So when I click on that, I will come to this one. Then I will select 16. Again, click on OK. I will click on apply. Click on apply. Then I will close. Then the last one is the your technical option. So under your technical option, I will click on stress. Then I will just assume my soil bearing capacity to be zero. I'll assume it to be uh, uh, 0 0.02 megapascal. Then I will so I will assume this to be 0.2 megapascal. Then I can save this as 16 also. Save this as 16. Then I will close. So I've done all the all the setting. So my footing is now ready for me to design. So what I will do next is to click on the start calculation button. So I will click on this. So my footing has been designed. As you can see that the actual size of this footing is 1.4. The actual size of this footing is 1.4. So let's look at the results. We look at the result here. So you can see here that under capacity, you can see that the capacity is 0.19 megapascal, which is okay, which is within what we have assumed, which is 0.2 megapascal. So that one has passed. That one has actually passed. So you can see our load, our load, our load under serviceability. You can see our load under serviceability and also the movement on the x-axis and movement on the y-axis. You can see it. Then you can also see the this thing under ultimate limit state. You can see it. So you can click each of these for you to have a view of their respective load. Remember that we are designing the entire column, the entire footing. So it's not just one footing, but the entire footing. So that is why we are having this. Okay, so let's move to the foundation reinforcement. So we move to the foundation reinforcement. So you can see this is the foundation reinforcement. So here you can look at this. So you can look at this. So you can look at this. So these are footings. These are footing. So here you can look at the notes. You can look at the notes. These are all the footing that has been designed. All the footing that has been designed. These are all the footing that has been designed. So now if you want to generate a calculation sheet, what you do is you come under results. When you come under result, you come under calculation notes. When you come under calculation note, what you do here is that if you want to include everything, you can, then you don't uncheck anything. But if you want to select some information, you can actually uncheck some of these. But I don't want to select anything, so I don't want to exclude anything, so I just click on OK. So when you click on OK, it will take you to this this environment. Here you can now edit whatever that you want to edit. But here I want to screen capture my design. So I just click on screen capture. So I can say that this is a footings design, footing design, footing design new, footing design new. I will click on OK. So when I click on OK, I'll click on OK. So when I do that, I now come to file. I click on print composition. So when these come out, I'll click here, then click on add. Then I can decide the format I want it to be printed out. So I can use Word. Okay, maybe it's like it's not responding to Word, so I can I can I can I can close it, then come back to this, click on this one, then I can look at the preview of it. Let me look at the preview of it if it's going to work out. Okay, the preview is not working out, so we can save it direct. We can save this direct without going through this process. So we can just save this file. We can save this file direct. We can save it. So you click on save as. Save as. So I can save it, and I will now decide if I'm going to use text to save it. So whatever I want to use, I can now decide here. So I can use this one and maybe save it as calculation for footings. So I'll click on OK. So I'll just click on OK. So let's go back. We go back to the reinforcement. So let's quickly click on the drawing so that we can look at how the drawing look like. So this is how the drawing look like. This is how the drawing look like. This is how it looked like. This is how it looked like. So let's quickly go back to our model. Let's go back to our model. So you can see that the entire footings has been designed. So that is how you can, design your structural members in robot. So we can look at this we can look at this in a 3D. Can look at this in a 3D. So look at this in a 3D. So let's okay. So from here, so you can see that all our this thing has been designed. All our footings has been designed. All the footings has been designed. So that is how you can perform your design for structural members in robot structural analysis professional. So thank you. I believe that you have learned something today. So in our next module, we are going to update this. Okay, let me just quickly update that so that we can know that next when we come, we just do the detailing. So let me quickly update this. Let me quickly update this. Let me quickly update this. So you can see how you can update the model in Revit. How you can update this in Revit. Okay, so this is what we do. This is the design. So we quickly click on it. Quickly click on it. Okay, so we can change this. We can change this from the analytical model to the 3D view of it. So this is our design. So let's just update this. So to update this from robot, you simply come to analyze. Simply come to analyze. So when you come to analyze, you click on robot. You will now see that it will tell you robot structural analysis link. Robot structural analysis link. So we are going to update this design that we have done. We are going to update this design that we have done. We are going to update it now in Revit. So all the reinforcement that has been provided, both in the base, the beams, the column, we are going to update them right now in Revit structure. So to do that, you just open the same model here. So you come here, click on robot. So you click on update model, update model. So you simply click. It's gonna update the model automatically. So in our next model, we do the detailing from Revit structure. So it's running the update now. It's updating it now. So you can see update model from robot. So it's updating the model from robot now. Updating everything that we have done from robot. So this, so it has finished updating the model. Say update from robot analysis file is completed. Command completed successfully. Do you want to see the events report? Yes. Okay, so we can close. So everything has been updated now. So in our next model, we will start the detailing from Revit. So thank you very much. I believe that you have learned something today.